Welcome back. In this section of the program, we deal with the technique of correctly triggering the oscilloscope. Triggering the horizontal time base is one of the most difficult adjustments to perform because of the many options available and the exacting requirements of certain signals. In this program, we have seen how signals applied to the vertical amplifiers of the scope deflect the beam up and down the screen, whilst at the same time the horizontal time base sweeps the trace across the screen from left to right. Successfully triggering the time base involves extracting a trigger signal from the incoming signal to be displayed, which will inform the time base when to begin tracing out the signal. When the scope is correctly triggered, the sweep will be synchronized to the incoming signal, so producing a stable, readable waveform. Let's investigate the functions of the trigger controls, starting with the trigger mode selector. 4 options are available. Auto is always the best mode to begin with, since the time base is free running and will always show a horizontal trace on the screen. Normal, for example, will only trigger the time base when a signal is present. For this reason, the normal mode is used when viewing signals with low repetition rates. TVV and TVH are used to display television-related signals, since this mode ensures that the time base will always be synchronized to the incoming vertical or horizontal television signals. The next step is to choose the origin of the trigger signal, which is controlled by the source selector switch. The setting is normally internal, which means that the trigger signal is extracted from either channel 1, channel 2, or both vertical inputs. Selecting line causes the time base to run at the power line or mains frequency, and is useful when analyzing power control equipment such as DC and AC drive systems, whose circuitry is all mains frequency related. The external position simply means that the trigger signal is derived from an external source and fed to the scope via an external input BNC connector. For example, when examining the head output signal of a video cassette recorder, the trigger must be externally derived from the head switching pulse circuit, since the head signal itself is unable to provide a reliable trigger signal for the horizontal time base. When viewing very small amplitude signals, it is a good idea to make use of the ×5 magnification facility to amplify the signal. The actual amplitude of the signal is then 5 times the value indicated on the volts per division switch. Having decided on the mode and source of the trigger, we must decide whether the time base must be triggered on a positive or negative edge of the incoming signal. This is set by the slope switch. Finally, the level at which the trigger will occur is determined by the trigger level control and can be set to any position on the positive or negative slope of the signal. As a rule, always choose the signal with the steepest slope and the least amount of jitter for reliable triggering. For slow rising waveforms, we use the midpoint, as this area is usually the cleanest part of the transition. To demonstrate the action of these controls, the start of the trace has been positioned so that it is easily visible. Note that the start of the trace represents the actual trigger point of the time base. Switching the slope switch to positive and then to negative clearly shows the time base firing on a positive going or negative going transition of the signal under test. Adjusting the trigger level control shows how the trigger position can be shifted along the positive or negative excursion of the waveform. To conclude this section, remember that the trace is only stable when the time base is properly synchronized to the incoming signal. During the break, we suggest you practice triggering the scope with a variety of different signals.